In this video, we are going to begin our discussion on circles. So let us first check out some of the important terminologies that we must know when we are dealing with circles. The first term is a chord. So a chord is any line which is joining 2 points on the circumference of a circle. So take any 2 points on the circumference of a circle, join it with a line, and that line will be called a chord. A special case of a chord is a diameter. So diameter is that particular chord which is passing through the center of the circle. So if you take two diametrically opposite points and join them, you will get a diameter. Then there is secant. Secant is a line which is intersecting the circle at 2 points. So chord remains within the circle, but if you extend the chord, it will be intersecting the circle at 2 points. That line is called a secant. Then we have a tangent. Tangent is a very special line. It is a line which touches the circle at only 1 point. And this point at which a tangent touches the circle has special properties. We will look at those properties later. But whenever we have questions related to circles, we very often see tangents in them. So we will discuss about the special properties that tangent has with the circle. So 3 things here. One is a chord. Special case of chord is diameter. If the chord is extended beyond the limits of the circle, it is called a secant. And if a line is touching the circle at only 1 point on the circumference, then it is called a tangent. Now let us look at some important properties of these things. So suppose we have a circle and there is a point outside the circle. So this point P. Now if I am drawing 2 secants from this point P to the circle. So this first secant is going from P to A to B. So it is intersecting the circle at A and B. The second secant is intersecting the circle at C and D. Now in this situation there is a particular property fulfilled, which is PA into PB is equal to PC into PD. So the multiplication of length of PA and PB and multiplication of length of PC and PD, this is going to be same. So this is a very special property which happens only if you draw 2 secants from a point exterior to a circle. Whenever you see such a situation where there is a circle and there is a point outside of it and 2 lines are drawn from that point and they are cutting at 4 different points, then remember that there is this property of PA into PB is equal to PC into PD. This may come handy in that situation. Now from that same point P, if I draw a tangent, so let us say that tangent is touching the circle at T. Now we do not have 2 points like we had earlier. We have only a single point. But here we can say that the 2 points are lying on this single point only. So PA into PB is also equal to PT into PT. So in this same scenario, this PA into PB is equal to PC into PD is equal to PT into PT. The next property is that if you have 2 tangents drawn to a circle from an external point. So suppose there is a circle and you have an external point A. Always you can draw 2 tangents to the circle from that external point. And the 2 tangents that you draw, these will be of equal length. So AC is equal to AB. And just look at the 2 triangles that are created by these 2 tangents. Since AC is equal to AB, this line AM is common. The line CM is equal to line BM because this is the radius of the circle. So you can see that these 2 triangles are congruent. So if there is a point outside a circle and you draw 2 tangents and you create 2 triangles, these 2 triangles are going to be exactly same, just a mirror image of each other. The next property written here is, if you draw a tangent, it is going to be perpendicular to the radius. So this angle which is marked 90 degrees here, this is always going to be 90 degrees. Then a perpendicular drawn from the center of the circle to a chord. So if there is a chord AB, you draw a perpendicular on that chord from the center of the circle, it is going to bisect the chord, that is AC is equal to BC. Then if you have two chords that are equal in length, then they are also equidistant from the center. So if you have another chord here, so if AB and PQ are equal, then the length of the perpendicular that you draw from the center, this is also going to be same. So OS is equal to OC. So this goes vice versa also. So if the perpendicular bisectors are equal, then the chords are also going to be of same length. Now here are some situations when we have two circles, how many tangents we can draw. So in the first image, where we have one circle inside another circle, can you draw a tangent which is common to both? So there is no such position where you can draw a tangent which is common to both. So 0 tangents can be drawn which is common to both. Then in this situation where there is one circle inside another circle, but they are both touching at a single point. So at this single point, you can draw a tangent, and this is the only tangent that you can draw which is common to both. So this line, which is a tangent to these two circles, it is called a common tangent. So only one common tangent can be drawn in this situation. Now here is another scenario. Here you have two intersecting circles. This may seem that they are both equal, but even if they are not equal, whenever you have two intersecting circles, you can draw two common tangents, just as we have shown here. Then there is this special scenario of intersecting circles when you have separated the circles and they are just meeting at a single point. Then one additional tangent can be drawn at that point of touch, which means that now we have three common tangents. Then this scenario where the circles are far apart, then you can have four common tangents, just as shown in this diagram. So the circles need not be of the same size. Even if one circle is large, the other is small, you can have four common tangents when the two circles are not touching and they are at a distance from one another. We are looking at this because in a lot of questions which have circles, we usually get multiple tangents or common tangents, or we may have to draw common tangents to solve the problem. In a question related to circle, using tangents is very common. So if you see multiple circles, you must know how many common tangents can be drawn on those two circles. Then lastly, there is this concept of concentric circles. Concentric circles means that two or more circles are having same center. So their centers are coinciding. So these are concentric circles. Their radius may be same or they may be different, but the center point is going to be the same. Now we are going to look at properties of arcs. So arc is basically any portion of a circle. So suppose I take 2 points A and B. I can go from A to B via this smaller path on the circle via C. So this ACB, this smaller arc is called a minor arc, and the larger arc is called the major arc. So ADB, this is the major arc. Now these arcs can have special properties. For example, here we have 2 points A and B. Now from A and B, suppose we draw two chords which are meeting at X, and we draw two chords which are meeting at Y. We are also connecting A to the center point O and B to the center point O. Now three angles are formed. One is angle AXB, one is angle AYB, and one is angle AOB. Now the first property is that angle AXB is going to be half of angle AOB. That is, angle AOB is equal to twice angle AXB. Similarly, angle AOB is going to be twice angle AYB. In other words, if you have 2 points on a circle, the angle made by those 2 points at the center is going to be twice the angle made by those 2 points on any point on the circumference of that circle. So even if you take any other point on the circumference of the circle, that point will also have an angle which is half of the angle made on the center. The next property is that the angle made on the circumference is always going to be the same. So angle at this point, or angle at x, or angle at y, all of these angles are same. And these are half of the angle made at the center. The next property is related to a tangent and a chord. So suppose we have this chord ST. Now at one point on the circumference where the chord is meeting the circle, there we draw a tangent. So this PQ is a tangent which is touching the circle at point T. Now the angle between this chord and the tangent, that is angle PTS, this whole angle, this angle is going to be equal to the angle made by this chord in the alternate segment. So this angle PTS is going to be equal to the angle TRS. So we have said that this will be equal in the alternate segment. This means since this angle is on the right hand side of point T of this chord ST, this is on the right hand side. So on the left hand side, if you touch any point on the circumference, say point R, then the angle made there, these two angles will be equal. If we are looking at the left hand side of this arc, so this angle STQ, this is going to be equal to the angle on the alternate segment, so SUT. So in the question, if you see that there is a chord and at one point of that chord you have a tangent, then remember to use this property that the angle made between the tangent and the chord is going to be equal to the angle made by that chord in the alternate segment. The next property is related to semicircles. So if there is a diameter or 2 points which are diametrically opposite, then the angle made by those 2 points or that diameter on any point in the circumference is going to be 90 degrees. This can also be deducted. This can also be deduced from this property that angle AOB is equal to twice of angle AXB. So angle ACB, this is O. So angle AOB, this angle 180 degrees, is twice of angle ACB. So you can say that since this is 180 degrees, any angle created by this diameter on the circumference is going to be 90 degrees. Now lastly, let us talk about the perimeter and the area of a circle. In a circle, we only need to know the radius or the diameter of the circle. If we know the radius, the perimeter of a circle is 2 pi r, and you can replace 2r with diameter. So the perimeter is going to be pi d. The perimeter of circle is also known as circumference. So circumference or perimeter of a circle is 2 pi r. The value of pi which we use for calculation purposes is 3.14. There are a lot of digits in the decimal places, but we just need to remember this much, that pi is equal to 3.14. To find the area of a circle, we can use pi r square or pi d square by 4. So if you replace r by d by 2, you will get pi d square by 4. So area is pi r square and perimeter or circumference is 2 pi r. Now let us look at some practice questions to understand these concepts better. There is a circle with center O. There is a point P outside. So this is actually a tangent. So it is touching the circle at T and S. We are given that PT is 24 centimeter. OT, that is the radius of the circle, is 10 centimeter. We have to find the value of PO. So I think this is pretty straightforward. If we remember that tangents are touching the circle at an angle of 90 degrees. So if you draw a radius at that point, the angle between tangent and the radius is 90 degrees. So this is a right angle triangle. We have the base, we have the height, we can find out the hypotenuse. So 24 square plus 10 square, 576 plus 100, 676. So PO is square of 26. So this is square of 26. So PO comes out to be 26 centimeter. So the concept here was that when there is a tangent and it is touching at a point and you draw a radius to that point, the angle between tangent and the radius is 90 degrees. Now in this problem, PA and PB are two tangents from point P to the circle. PA is given as 8 centimeters. Angle APB is 60 degrees. And we are asked the length of the chord AB. So let us look at this triangle APB. Angle P is 60 degrees. Since two tangents are being drawn from the same point, as we have said earlier, the length of those two tangents is going to be same. So PA is equal to PB. Since PA and PB are same, the angle A and angle B, they are equal. So this X is going to be 180 minus 60 divided by 2. So X is 60 degrees. So since all three angles are 60 degrees, this means that this is a equilateral triangle. That is, all three sides are same. So since we know one of the sides has 8 centimeter, AB is also going to be 8 centimeters. Now in this figure, O is the center and a circle is drawn. Now a point P is outside the circle and a tangent is drawn from this point, which is touching the circle at point T. PC is given as 3 centimeters. PT is given as 6 centimeters. Now we have to calculate the radius. So radius is OT or OC. So let's draw this radius OT. And let's name it as R. OT is R and OC is also R. And we know that this angle is 90 degrees. So we can apply Pythagoras theorem here also. PO square is equal to OT square plus PT square. So PO square is equal to OT square plus PT square. PO is the hypotenuse here because it is opposite to the 90 degree angle. So PO square is equal to OT square plus PT square. So PO is R plus 3 whole square of this is equal to OT square, which is R square, and PT square, which is 6 square. So the equation is R square plus 3 square plus 2 into R into 3 is equal to R square plus 6 square. We can cut R squares. So this becomes 6R is equal to 9 plus 6R is equal to 36. So R is equal to 27 by 6, which is 4.5. So we have used the same concept here, that tangent is at 90 degrees with the radius. Remember, you may have to draw the line from center to the point of touch of tangent and circle, and that is going to be equal to the radius. Now here we have a circle again with center O, and on this circle a tangent is drawn, which is TAS. So it is touching the circle at point A. Angle OBA is given. OBA, this is 32 degrees. And we have to find the value of X, that is angle BAS. Now in this diagram, additional lines have been drawn to confuse you. So you may be thinking that we must use this point C. There is some angle made at this point. Maybe we have to use the concept that angle AOB is twice angle ACB. Nothing of that sort is important here. we have to find angle BAS. We know that angle OAS is 90 degrees because the angle between radius and tangent is 90 degrees. Now we want to find angle BAS. So angle BAS is equal to angle OAS minus angle OAB. We have to subtract this angle from 90 degrees to get angle X. And we know that in triangle OAB, OA and OB are same because these are radius of the circle. So the opposite angles are also equal. Angle OAB is equal to angle OBA. So this is also 32 degrees. So to find X, we just have to subtract 32 from 90 to get 58 degrees. So in the diagram, we may be given some additional lines or angles. Do not get confused. Work step by step. Check out what you have to find out and stick to the points that we have discussed to reach at the solution. Now let us look at some of the questions that we can get related to circles. So this is a very simple question. In this question, we are given that in this circle, we have to find the value of X. So this is X and we are given that angle ABC is 110 degrees and angle BDC is 30 degrees. Now whenever we see that from 2 points of a chord, we have joined 2 points on the circumference of a circle. We should remember that rule that the angle made by a chord is going to be same on both the points. So angle BDC is going to be equal to angle BAC. So this means that angle BAC is 30 degree. Now if you look at triangle ABC, we know angle A, we know angle B. We can find the angle ACB. Plus X is equal to 180 degrees. This means that angle X is 40 degrees. So this was a straightforward question where we had to use the property that angle made by a chord on circumference is going to be same. Now in this question we are given that there are two circles, a smaller circle with radius 6 cm and a bigger circle with radius 8 cm, and they are cutting each other at right angle. So what this means is that at the point of intersection, if you draw the radius of the two circles, so these two radiuses are at 90 degrees. Now we have to find the length of the common chord. So common chord is the connection of these 2 points. So this chord is common chord. Common chord is not the connection of the two centers. So you may be thinking that we have to find the length of these two centers, which is going to be straight away the length of hypotenuse. That is not true. We have to find the length of AB. Now first of all, we can easily find out O1, O2 distance. So we know that the base of this triangle is 6 cm, height is 8 cm, so hypotenuse is equal to 10 cm. So O1, O2 we know is 10 cm. Now for the triangle AO1, O2, the area of this triangle can be calculated in two ways. Now if we join O1 with B and O2 with B, you can see that the two triangles opposite to the line O1, O2, these two triangles are same. They are congruent since all the three sides of these triangles are same. Now let us mark this intersection point as T. Now look at these two small triangles AO1T and TO1B. In these two triangles, AO1 and O1B are same. These are the radius. O1T is common between these two triangles, and this angle AO1T and BO1T, this is same because we have seen that the bigger triangles were congruent. This means that these two smaller triangles AO1T and BO1T are also congruent. This means that the line AT is equal to line BT. And we have also seen in the previous video that if a line from center is bisecting a chord, then that line is perpendicular to the chord. So therefore, we know that AT is perpendicular to O1, O2 and AT is half of AB because AT and TB are equal. So AT is half of AB. Now, to find the value of AT, let us look at the triangle AO1, O2. We can calculate the area of this triangle in two ways. If we take AO1 as the base, then half base into height is going to be half AO1, which is 6, and height, which is 8. The other way of looking at the area is if I take base as O1, O2. So the area will be half O1, O2 into height, which is 80. So O1, O2 we know is 10. So half into 10 into 80 is equal to 24. So this gives us that 80 is equal to 4.8. Now AB was twice of 80. This means that AB is 9.6 centimeter. This is the length of the common chord. So few important concepts were used here. One was to identify congruent triangles. The other was that a line from center to a chord which is bisecting the chord is also perpendicular to the chord. And the other was the use of Pythagoras theorem when we know that there are some 90-degree angles created in a diagram. So we used Pythagoras theorem and the area of triangle to find out the length of AT. Now in this question, a square is inscribed in a semicircle of radius 10. So there is a semicircle. In that semicircle, a square is inscribed. We have to find the area of that inscribed square. And it's given that a side of the square is along the diameter of the semicircle. So this is the situation exactly. So first, since this is a square, all the sides are going to be of same dimension. So we can straight away put that the dimension is A. Now you have to think of this problem from the point of view of symmetry. If you have to inscribe a square, that square must be placed in such a way that it is symmetric along the center. Suppose it is not symmetric. So suppose the point C and D are, say, D is here and it is touching the circle there, and C is here and it is touching the circle there. So you can see that this is not going to be a square. For a square which is having a side along the diameter, such a square must be symmetric along the center. This means that the distance of C from O will also be equal to distance of D from O. With this simple logic, this problem becomes very easy. So if you look at the triangle OBC, we know side BC is A, side OC is A by 2, and side OB is the radius of the semicircle, which is given as 10 centimeter. And since this is a square, we know that the angle is 90 degrees here. So we can apply Pythagoras theorem and write r square is equal to a square plus a by 2 ka square, a square by 4. So 4 by 5 into 100 is equal to a square. So a square is 80. And we were asked the area of the square, which is a square only. So area of square is a into a. So this is 80. The problem will become easy only if you look at it from the perspective of symmetry. the square has to be inscribed inside a semicircle and one side is along the diameter of the semicircle, then the square will be symmetrically distributed along the center. Now let's look at another question. In this question we are given two equal circles. So both of these circles are equal of radius 5 cm. Now there are two common tangents AB and CD. We are given the length of CD. So C to D is 24 centimeters. And we have to find the length of AB. Since we have tangents and we know an important property that radius at that point where the tangent is touching is at 90 degrees. So let us draw the radiuses to the first tangent. So we have drawn two radiuses and they are at 90 degrees. And let us join their centers also, these two circles center. So let's say the center is O1 and O2. Now you can see that in this figure AB, O2, O1, two of the angles are 90 degrees and both the radiuses were equal. You can see that this is a rectangle. So AB is also equal to O1, O2. We have to find AB. We can find O1, O2 also and that will be same as AB. Now let us look at the other tangent. The other tangent was CD. Let us draw the radiuses at point C and D. So we have these two 90 degree angles also. Now look at these two triangles. Let us name this intersection point as T. Now let us look at these two triangles O1CT and O2DT. These two triangles, let us look at them. The angle at T in both the triangles is going to be equal because it is opposite angle of two intersecting lines. So this angle is equal. Then that angle which is made with the tangent, that is 90 degree in both the triangles. So that is also equal. This means since two of the angles are equal, this means the third angle is also equal. So these two are similar triangles because all the three angles are equal. Apart from that, we are also given that both of them have the same radius. So these two sides are also equal. This means that not just similar, these two triangles are also congruent. If these two triangles are congruent, that means that O1T is also equal to O2T. This means that O1T is half of O1, O2. We can also say that CT is equal to DT or CT is half of CD. So we know CD is 24 centimeters. So CT is 12 centimeter. Now if you look at the right angle triangle O1CT, we know O1C is 5 centimeter, CT is 12 centimeter. We can use the Pythagoras theorem to find O1T. So O1T square is 5 square plus 12 square. This comes out to be 13 square. So O1T is 13 centimeter. We want to find out O1, O2, which is twice of this. So 26 centimeter. And this is the length of AB, which we wanted to find out. So you can see that although this was a question about circles and we used some properties of tangents and circles. However, in the end, a lot of the concepts of triangles are being used to solve these questions, where we have to find whether the triangles are similar or congruent and which angles of these triangles are going to be equal and which sides are going to be equal. Now in this question we are given that there is one large semicircle in which two circles of equal radii are drawn. There is no overlap between these two circles. the radius of the larger semicircle is 2 centimeter. Now we have to find out the largest possible circles that we can draw within this semicircle. So we have to find out the radius of these two small circles that have been inscribed inside the semicircle. Now let's first mark the important points in this figure. There is this big semicircle. It has a center point. Let's mark the center point as A. Then we have two smaller circles of equal size. Let us name their center as B and C. Then these two circles are going to touch the bigger semicircle at 2 points. So these points, let's call them PQ. And these two circles are also going to touch each other at a point. Let's call this point as T. The smaller circles will also touch the semicircle on the diameter of the semicircle. Let's call these points as X and Y. Now let's look at the smaller circle on the right. That smaller circle is touching the larger semicircle at point P. So let's draw a common tangent at point P. So L1 is a common tangent. Now if we draw a line from C to P, this line is perpendicular to L1 because CP is a radius and L1 is a tangent. These two will meet at 90 degrees. Similarly, if I draw a line from A to P, this AP line is also perpendicular to line L1. So this angle is also 90 degree. Since both the lines CP and AP are at an angle of 90 degrees and they are both meeting at the point P, this means that points A, C and P are collinear. That is, point C lies on the line AP. So this is one straight line AP and C is on that line only. Now since both the circles are equal, so we know that this point T is going to be on top of point A. That is, this figure is also symmetric along the line AT. So BT is equal to CT because both these circles are equal. This figure is also symmetric along the line AT. Now if I join point CY, since the diameter of the semicircle touches the circle at only one point, this diameter is like a tangent to the circle. So the angle between CY and the diameter is 90 degrees. We know that CY is equal to radius R. AY, which is same as CT, is also equal to radius R. And what is the length of AC? And AC is equal to AP minus CP. So AP is the radius of the larger semicircle. So AP is equal to 2 centimeter. And CP is the radius of smaller circles, which is R. So AC is equal to 2 minus R. Now we can apply Pythagoras theorem in the triangle ACY, where angle Y is 90 degrees. So AC square is equal to CY square plus AY square. 2 minus R whole square is equal to R square plus R square. 4 plus R square minus 4R is equal to 2R square. So R square plus 4R minus 4 is equal to 0. So we have to solve this quadratic equation. So we will use the formula minus B plus minus under root B square minus 4AC divided by 2A. Let's put these values. Minus 4 plus under root 16 minus 4 multiplied by minus 4. So this becomes plus 16 since c is minus 4, so this will become plus 16 divided by 2a. A is 1, so 2. So this becomes minus 4 plus minus under root 32 divided by 2. So 4 root 2. So since we want a positive value, we will ignore the negative solution for this. We will have minus 4 plus 4 root 2. So under root 32 is equal to 4 root 2. Divided by 2. So this becomes so if you multiply 2 with 1.41, this comes out to be 0.828. So in this problem also, we use the concept that tangent is touching the radius at 90 degrees. We use the concept of symmetry, Pythagoras theorem, and how to solve a quadratic equation to achieve this final solution. That's all in this video. See you in the next one.